We know that the normal and axial forces acting on the body are the results of the pressure and shear stress distributions. So, these distributed loads create a moment around the leading edge. Wait a second. If we specify the aerodynamic force on a body as a single resultant force R, or its components N and A, where should this resultant force be positioned on the body? We solve this by placing the resultant force in a way that it produces the same effect as the distributed loads. For instance, considering the distributed load on a two-dimensional body such as an airfoil, it generates a moment around the leading edge. As a consequence, N and A must be positioned on the airfoil in such a manner as to produce an equivalent moment around the leading edge. If A is situated on the chord line, then N must be positioned at distance xcp downstream of the leading edge such that the direction of the curled arrow representing M at the leading edge is drawn in the positive sense if pitched up. This follows the standard convention, but in the figure we have a positive N which creates a negative moment, so that explains the equation. In this figure, xcp is defined as the center of pressure and represents the location where the resultant of distributed load effectively acts on the body. It's worth noting that in cases where the angle of attack is small, sinus of alpha close to 0 and cosine of alpha equals to 1, we have L pretty close to N, so we can rewrite the equation like this. Analyzing these two equations, we observe that as N and L decrease, xcp increases, and as the forces approach 0, the center of pressure moves to infinity. This leads to the understanding that the center of pressure isn't always a convenient concept in aerodynamics. However, it doesn't pose a problem as the force and moment system due to a distributed load on a body can be defined by placing the resultant force at any point on the body, if the value of the moment about that point is given. For example, this figure illustrates three equivalent ways of specifying the force and moment system on an airfoil. In the left figure, the resultant is positioned at the leading edge with a finite value of moment. In the middle figure, the resultant is placed at the quarter chord point with a finite value of moment chord over 4. In the right figure, the resultant is placed at the center of pressure with a 0 moment about that point. We can write the relation between these cases such as